Hello everyone. In this video, we are going to see two more problems in power electronics. The problem is a self-commutating switch SW operated at duty cycle delta is used to control the load voltage as shown in the figure. Under steady state operating conditions, the average voltage across the inductor and the capacitor respectively are. The circuit is given here. From this circuit is a self-commutating, it is having a self-commutating switch of SW, which is operated at duty cycle of delta. So here, the first task is to identify what is the type of converter. What type of converter is this? So from the circuit diagram, we can easily find that this circuit is a step-up chopper. That is, this circuit is a boost converter. So you have a self-commutating switch which is operated at delta, that is duty cycle delta. And it is given that we need to find out the average voltage across the inductor and the capacitor. So there are four options given. Option A is VL equal to 0, that is average voltage across the inductor is equal to 0, and VC is 1 by 1 minus delta VDC. Option B is VL equal to del by 2 into VDC, and VC is equal to 1 by 1 minus del into VDC. Option C is VL equal to 0 and VC is equal to del by 1 minus del into VDC. And option D is VL equal to del by 2 into VDC and VC is equal to del by 1 minus del into VDC. So we all know that the average voltage across the inductor of a DC to DC converter is always 0. And since this is a boost converter, this is a boost converter. So the voltage across the capacitor, which is nothing but the voltage, output voltage, is given by 1 by 1 minus duty ratio into input voltage. So so the option A will be the correct answer, because VL average inductor voltage is 0, and VC, which is nothing but the output voltage, which is equal to 1 by 1 minus del into VDC. So the first option is the correct option. So next problem is a step-up chopper is used to feed a load at 400 volt DC from a 250 volt DC source. The inductor current is continuous. If the off time of the switch is 20 microsecond, the switching frequency of the chopper in kilohertz is dash. So this is a numerical answer type problem where we need to find the switching frequency. We all know that for a step-up chopper, the output voltage is V0 equal to Vs by 1 minus K. And V0 is given as 400 and Vs is given as 250. So 400 equal to 250 divided by 1 minus K. From this, we need to find out what is K value. So K value, it is obtained as 0.375. K is nothing but T on by T. So T on by T is equal to, we can write T on as T minus T off. So T minus T off divided by T is equal to 0.37. And it is given that T off is 20 microsecond. From here, we can find the value of T as 3.2 into 10 power minus 5 seconds. So by substituting T off equal to 20 microsecond, we can find the value of T, that is the time period of the switch, as 3.2 into 10 power minus 5 seconds. And we can find the switching frequency F is equal to 1 divided by T, which will be equal to 31.25 kilohertz. So this is the required answer. The switching frequency of the chopper in kilohertz is 31.25. Thank you.